All right, let's do some slightly more advanced questions. Not really that advanced, but you'll see what I mean. So for the curve, y equals x to the power of 4 minus 3x squared plus 1, which is that one just there. Find the coordinates of the point where the gradient is 0. Okay, what does it mean when the gradient is 0? It means it's flat. It's not going up at all. It's only going sideways. Right? So we can see that it is at that point there. At that point there, it's flat. And at that point there, it's flat. Notice that it's flat at a turning point, at an extrema. So these two are turning points, and they are minima because they're a minimum value. This is a turning point as well. This is a maxima. This will be important a little bit later on, probably actually in the next lesson. It's really, really important to be able to find where these turning points are. And we can find the turning point by setting the gradient equal to 0 and finding out where that is. So let's do that now. So if we know that y is this thing here, we know that dy dx is going to be whatever this is differentiated. So we bring the 4 out the front. Times minus 3 is minus 6x, and 1 disappears. What do we do then? Well, we set that equal to 0 and solve. Okay. So for this one here, I'm not going to do it algebraically. I guess we could actually factor out an x. We could say that that's x, 4x squared minus 6 equals 0. So x equals 0 is a solution. And if you look there where x equals 0, that is actually a turning point and it's a maxima. But what are the other two? Well, let's cheat. Let's use our calculator. We're going to put that in and solve it. So we're going to go to menu, and there's a couple of ways we have of solving. I guess we'll do both now that I see that. F2 for the polynomial solver. It's a degree 3 because it's 4x cubed. So then it's 4x cubed and then plus 0x squared minus 6 and the d is also 0. There is no constant. And then solve it. So we can see here that the answer is at 1.2247. This thing here, 0 and minus 1.2247, which is kind of what we see there, minus 22.47 and plus. So that's going to be our the x values of our coordinates. So it's going to have turning value, it's going to have gradient equals 0 when x equals 0, but we already worked that out. When x equals, what did I say, 1.2247 and x equals minus 1.12247. And then we would put in these values into the original equation and find out what it was. Let's do it for 0. So the original equation is y equals x to the power of 4 minus 3x squared plus 1. If we set x equal to 0, that's going to be equal to 0 to the power of 4 minus 3 times 0 squared plus 1. Well, that's 0 to the power of 4 is 0. 3 times 0 is 0 plus 1 is 1. So 0, 1 is going to be one of the turning points. And if we have a look, sure enough, that is one of the turning points there. Let's use the calculator to find the actual turning points for the other ones, but let's use the graphing function instead. So we would come along to graph, we would put in the original function, so x to the power of 4 minus 3x squared plus 1. We're going to draw it. You see it's the same graph. Now we're going to go to gsolve, and now we're going to use the maxima and minima. And we know that we're looking for these two minima, so let's find the minima point, and that's what we had before. And then we go along here and find the other minima point, which is there. And if we wanted to prove that that's maxima point is at 0, 1, it's going to tell us when x equals 0, y equals 1. That's the other that is the only maximum point. So notice these are local minima and local maxima. It's not an absolute maxima because it goes on for infinity there and goes up to infinity there. These are absolute minima here because the lowest value it will have is that and that. It's never going to go below that. This next question asks you to find the equation of the tangent to the curve where x equals 1. So here's x equals 1 here, so we want to find the equation of that line there. So what do we need to do? We need to find the slope. So remember that the slope, which we would previously write as that, we can now do it by differentiation. So we need to differentiate that, so dy over dx. So the 3 comes out the front and it loses 1, and the x goes away and we just have negative 4. So that's the gradient function. So that tells us the gradient for a value of x. Let's cut and paste x equals 1 in there. So 3 times 1 squared minus 4. So that's going to be 3 minus 4. That's negative 1. Sorry, someone knocked on my door. So the gradient is going to be at negative 1. So we almost have enough to solve this now. We need to know where this point is now. We know that it's at positive 1. It looks like it's at around negative 3, but let's make sure. So we go to the original function. So 1 cubed minus 4 times 1. So 1 minus 4 is indeed minus 3. So this point here is at 1, negative 3. And now we know the gradient. We know one of the points. So our formula for finding that is y minus y1 equals mx minus x1. So y1 is going to be negative 3. So y negative 3 is plus 3. And it's going to be equal to negative 1 x negative 1. So y equals, I'm going to bring that 3 over, negative 1x plus 1 negative 3. So this the equation of the line that goes tangent at that point there is going to be minus x minus 2. Okay, the next one. Find the coordinates where the tangent has a slope of 7. So here is the graph there. Well, the slope of 7 is going to be fairly steep, so it's going to be kind of somewhere around here somewhere, I'd say. And notice that it's also probably around about here somewhere as well. So let's work it out. So we are finding tangent. That's our clue that we're going to be differentiating. So if y equals 2x cubed minus 3x squared plus x dy dx. So what we get when we differentiate, 3 times 2 is 6. The 3 loses 1. 2 times minus 3 is minus 6. X to the power of 1. And there's a 1 in front of the x there, and there is a 1 there. 1 times 1 is 1. So that's the function that will give us the gradient at any point, but we're looking for the x coordinates where that gradient equals 7. So 6x squared minus 6x plus 1 equals 7. Can we solve it? Well, we could solve it. We would need to factorize and do algebra on that, but let's bring that 7 across. 6x squared minus 6x, and now it's going to be minus 6, I guess, equals 0. We could divide all of it by 6, I guess. Put it in the calculator and solve. So we're going to go to polynomial solver. It's a degree 2 because there's the biggest number is 2. And let's just put in the all of the 6's in there. XE, and here we have our 2 answers. So our first answer is 1.618, which is about there. So that's where the gradient is at 7, and the other one is at minus 0.68, so it is around about there, I guess. That's where the gradient equals 7. All right, last question. The curve, this, so we know it's going to be a parabola because it's x squared. Find the coordinates of the point where the tangent is parallel to the line here. All right. Where 2 lines are parallel, the slope is the same. So this one here, what's going to be the slope of this line here? Well, if we know that the equation is that, if we differentiate that, we're going to get 2, which kind of makes sense. It tells us that the slope of the line everywhere is 2, and that just describes a line. For every one that it goes across, it goes up 2. That's just a line. So in other words, we want to find where in this function here does the gradient, where does the gradient equal 2? And when we find that, it's going to be parallel to this tangent here. So let's solve it. Where does this equal 2? Well, if the original line is that, and we want to find the gradient, we're going to need to differentiate it. So the 2 comes out the front. 2 times 1 is 2, and there's a 1 here, so 1 times negative 4 is negative 4. The 3 goes to nothing. Where does that equal 2? What value of x needs to be fulfilled in order for that to be true? Well, 2x minus 4, let's add 4 to both sides and divide both sides by 2, so it's where x equals 3. So for this function here, where x equals 3, the gradient is 2, which is parallel to this line here. So in other words, we have our parabola here, that point there, the gradient is 2, and that's going to be parallel to whatever that is, that line there. They're going to be parallel to each other, because when two lines are parallel, the slope is the same.